How are numbers represented? In daily life, numbers are expressed using the decimal system, which uses the digits 0 through 9. 10 ones make 10, and 10 tens make 100. In this way, place value increases based on powers of 10. This is the decimal system. But why 10? The reason is simple. Humans have 10 fingers. In the past, people rarely needed to handle large numbers. Counting objects by folding fingers one by one was the most intuitive and convenient method. This simple method has continued to the present. However, the decimal system is not the only way to count. Let's think of the days of the week. A week follows a base 7 cycle of 7 days, and a year is divided into 12 months, reflecting a base 12 system. Computers, on the other hand, operate using the binary system of 0 and 1. Different methods are used depending on the situation. Then why did the Babylonians use the base 60 system? The reason lies in the properties of the number 60. While 10 can be divided only by 2 and 5, excluding 1 and itself, 60 can be divided by many numbers, including 2, 3, 4, 5, 6, 10, 12, 20, and 30. For example, consider dividing something. Whether divided by 3, 4, or 5, 60 is usually evenly divisible. That is why the Babylonians chose the base 60 system. Today, calculators and computers make even complex decimal calculations easy. But just 100 to 200 years ago, decimal calculations were tedious and difficult. The decimal system has another advantage. The decimal system can represent not only large numbers, but also very small ones with ease. On a number line, dividing the interval between 0 and 1 into 10 equal parts gives 0.1, 0.2, and so on. Dividing each of those parts again into 10 yields smaller numbers, such as 0.01 and 0.02. In this way, a point on the number line can be expressed as a decimal. However, there is a limitation. The decimal system cannot represent every number as a finite decimal. For example, consider 1/3. In decimal form, it becomes 0.333 with 3 repeating endlessly. Some numbers appear as endless decimals like this. This shows a limitation of the decimal system, and at the same time, an advantage of the base 60 system. Now, consider the binary system. Binary expresses numbers using only 2 digits, 0 and 1. It is very simple, and that simplicity is its strength. Because only 2 values are used, the chance of error is low. However, it also has a drawback. Large numbers require many digits. Then where can binary be seen? Morse code conveys information using short and long signals, dots and dashes. Barcodes store information using black bars and white spaces. Turning a light switch on and off also resembles the binary system, since it consists of 2 states, on and off. Now consider a computer. Most electronic devices, such as smartphones, computers, televisions, and game consoles, are built with digital circuits. Although the inside of a computer appears very complex, its actual operation is simple. When the voltage in a circuit is high, it is on. When it is low, it is off. A computer interprets these 2 states as 1 and 0. However, a question arises. If the decimal system can express more information, why do computers use the binary system? The reason is stability. A transistor, the core component of a computer, turns on when an electrical signal is applied and turns off when it is not. A computer interprets this as 1 and 0. For example, if an electronic device uses 5 volts, 5 volts represents on and 0 volts represents off. What if a ternary system is used? 3 states must be distinguished, such as 0 volts, 2.5 volts, and 5 volts. What happens when ambiguous values like 1.5 volts or 3 volts appear? they become harder to distinguish accurately, and the chance of error increases. In a decimal system, such cases occur far more often. Computers use the binary system to reduce errors and improve efficiency in cost and time. In the end, numbers are not expressed in a single way, but in the most appropriate way for each situation.